We now discuss the solution of a problem from the section Vector Algebra. The problem is on projection of a vector. This question has appeared in the Joint Entrance Examination Main held on 25th June 2022 in the first shift. The given question is, let the vector A is equal to a1i plus a2j plus a3k, where ai greater than 0 for all I is equal to 1, 2, 3 be a vector which makes equal angles with the coordinate axes ox, oy and oz. Also, let the projection of the vector A on the vector 3i plus 4j be 7. Let the vector B be a vector obtained by rotating the vector A with 90 degrees. If vector A, vector B and x-axis are coplanar, then the projection of the vector B on 3i plus 4j is equal to, we are given 4 options. Option A, root 7, option B, root 2, option C, 2, option D, 7. We have a vector A given as a1i plus a2j plus a3k, where a1, a2, a3 are all positive, and given that this vector A makes equal angles with the coordinate axis, that is, equal angles with x-axis, y-axis and z-axis. It is further given the projection of the vector A on the vector 3i plus 4j is 7. We are also given B is a vector which is obtained by rotating this vector A by 90 degrees. If the vector A, vector B and x-axis lie in the same plane, that is, they are coplanar, then required to find the projection of the vector B on 3i plus 4j. We now discuss the solution of the problem in detail. We have vector A given as a1i plus a2j plus a3k, where a1, a2, a3 are all positive, and it is given this vector A makes equal angles. Let us say that angle is alpha with the coordinate axis, that is with x-axis, y-axis and z-axis. Then the vector A dot I, there is a dot product of A, the vector A with I. So a1i plus a2j plus a3k dot I is a1. Agreed. A dot I is mod of A into mod of I, that is 1, into the angle between A and I cos alpha, and that is A1 comes out to be mod A cos alpha. Because it makes the same angle, we will get A2 is equal to A3 is equal to, each is equal to mod A cos alpha. Now that means A1 is equal to A2 is equal to A3 is equal to mod A cos alpha. If I want modulus square of the vector A, mod A square is equal to A1 square plus A2 square plus A3 square. So each A1, A2, A3 is mod A cos alpha. That will be 3 times mod A square cos square alpha, and mod A square is there on the both sides, therefore 3 cos square alpha is 1, cos square alpha is equal to 1 by 3, therefore cos alpha is equal to 1 by root 3. Agreed. So therefore the vector A is a1i plus a2j plus a3k where A1 is equal to A2 is equal to A3 is equal to mod A cos alpha, and cos alpha is 1 by root 3. Each is equal to mod A by root 3. Therefore, mod A by root 3 into I plus j plus k. That is the vector A. We are given the projection of this vector A on this vector 3i plus 4j is 7. We recall the projection of a vector A on a vector B is given by A dot B by mod B. Here in our case B is 3i plus 4j, and that this implies the projection is A dot 3i plus 4j by mod of 3i plus 4j is equal to 7. Mod of 3i plus 4j is 5 under the square root of 3 square plus 4 square, that is under the square root of 25, that is 5. And the vector A we have written mod A by root 3 into I plus j plus k dot 3i plus 4j, and this is the projection. It is given to be 7. Now cross multiply, we will get mod A by root 3. If you cross multiply 5 into 7, 7 5s are, this is 7 into 5. Now I plus j plus k dot 3i plus 4j is I dot 3i is 3, j dot 4j is 4, the remaining are all 0. Then you will get mod A by root 3 into 7 is equal to 7 into 5, 7 cancels on both sides. You will get mod A is equal to 5 root 3. Thus, and mod A by root 3 will be 5. Therefore, your vector A is given from here, that is 5 times I plus j plus k. That is our vector A. We continue in the next slide. We have the vector A 5 times I plus j plus k, and modulus of the vector A is equal to 5 root 3. Agreed. Now, let B be a vector obtained by rotating A with 90 degrees. That means let B is the vector xi plus yj plus zk, and it is given the vector B is obtained by rotating the vector A with 90 degrees. That means A dot B is 0, because B is obtained by rotating A by 90 degrees. Therefore, A dot B is 0. Further, by rotating A, we got B. By rotation, then the modulus will not change. Therefore, mod of A is equal to mod of B. So, two things we will write. So, B dot A is 0 because it is 90 degrees, and by rotation, the modulus will not change. Therefore, mod B is equal to mod A. So, B is xi plus yj plus zk, A is 5y plus 5j plus 5k. If you take B dot A, it will be 5x plus 5y plus 5z is equal to 0. 5 is common, you will get take the dot product, and mod B is equal to mod A. Mod A is already we have written 5 root 3, and when you take the dot product, you will get 5y plus 5j plus 5k is equal to 0. 5 is common, so you will get x plus y plus z is equal to 0. Let's call the equation as 1, and from here mod B is xi plus yj plus zk. Therefore, mod B is x square plus y square plus z square is equal to, this is mod B square. This is mod B square. Mod B square is x square plus y square plus z square. So 5 root 3 square is 25 into 3. So we got two equations, x plus y plus z is equal to 0. Call this as the equation 1. X square plus y square plus z square is equal to 75. Call this equation as the second. Now, it is further given the vector A, B and x axis are coplanar. That means the vector A, B and I. On x axis we take I. They are coplanar. That means the box product of A, B, I is 0. That is the scalar triple product of A, B, I is 0 because they are coplanar. So we write down the determinant. This implies determinant. The components of A, first row, 5, 5, 5. Components of B, X, Y, Z, yes. Components of I, 1, 0, 0. So expand this determinant by the third row. You will get 5Z minus 5Y is equal to 0. This will imply Y is equal to Z. If you take Y is equal to Z and equation from the equation 1, X plus Y plus Z is equal to 0, X is equal to minus Y minus Z, then X will be minus 2Y. Minus 2Y. So X is minus 2Y, Y is Y, Z is Y. So we, therefore, our vector B, what is our vector B? Xi is minus 2yi plus yj plus zk, z is y, yk. So y is common, so my y common multiplied by minus 2i plus j plus k. Okay, we have from this equation, x square plus y square plus z square is equal to 75. So x square is what? X square is 4y square. Y square, z square is y square is equal to 75. That is equal to 6y square is equal to 75. That is y square is equal to 25 by 2. Y is plus or minus 5 by root 2. Wonderful, wonderful. So y is equal to plus or minus 5 by root 2. So therefore B will be what is B? Y into 2i plus j plus k written here. For y, you write plus or minus 5 by root 2. That's all. Multiplied by minus 2i plus j plus k. So we got B. We discuss further in the next slide. So we have the vector B is equal to plus or minus 5 by root 2 multiplied by minus 2i plus j plus k. And we want to find the projection of the vector B on 3i plus 4j. What's the formula? B dot the vector 3i plus 4j by modulus of 3i plus 4j. So for B, we write plus or minus 5 by root 2 multiplied by minus 2i plus j plus k. So we have written dot 3i plus 4j. Mod of 3i plus 4j is 5. 5 cancels. 5 cancels. So you will get plus or minus 1 by root 2 into minus 2i dot 3i is minus 6. J plus j dot 4j is plus 4. So that will be plus or minus 1 by root 2 into minus 2. That will be plus or minus root 2. So what is the answer? We want to find the projection of the vector B on 3i plus 4j. So what's the answer? The answer is plus or minus root 2. So let's look at our options. The answer root 2 appears against option B. Therefore, the projection of B on 3i plus 4j is root 2. So the answer to this question is option B. That is the detailed discussion of the solution of a given problem which is on the projections of a vector from the vector algebra. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.